Hello, good morning all of you. In the previous session, we looked into the control structures such as the if statements and its different variants. In today's session, we will look into another control structure, that is the switch statement. The purpose of using the switch statement instead of the if structures are that when the number of options that we have are minimal, maybe 2 or 3 options, then we might have to choose the if structures. And if the number of options are more like this, many more options, then we might have to make use of the switch statements. So, now let us see what a switch statement is and how it is used in the C programming language. So, here a switch statement allows a variable to be tested for equality against a list of values. So, you have all these list of values as the options. So, you are comparing with one requirement all these options, and when you find a match, you are going to execute the corresponding statement. Now, look into the syntax of the switch statement. We have a switch expression followed with several switch cases over here. We call this as the switch case, and all the switch cases are going to be prefixed by the keyword case. So, you have case, a constant expression followed with a statement or a set of statements and an optional break statement. So, this is going to be occurring again and again, that is how many ever options you have, you would be specifying so many switch cases. So, another case, constant expression. So, the same format what we have used over here, that would be followed for all the other switch cases. And apart from this, at the end maybe we are going to use a default keyword, where this default is going to help in case the expression in the switch is not going to match with any of these case values over here, then the default block would be executed. So, here you have a switch expression where this expression is going to be evaluated into a value or a literal, and then you have a case constant expression where this constant expression again would be matching with the expression, that is the data type should match necessarily, and then if any of these values are going to be equal to the expression evaluated over here, then that particular switch case would be executed. And suppose I am saying this break is an optional keyword. So, suppose break is not specified over here, what happens? If break is not specified, after executing this particular first switch case for example, then the control would be transferred to the next switch case again. So, that happens when you have not specified the break statement. So, that would be seeped into the next switch case, we can say. Suppose we have specified the break statement. A break statement in C programming languages is going to suspend the current execution and transfer the control to the next statement. So, here the next statement for us would be the statement following the switch block. So, here from this brace to this brace, it is called as one switch block. So, suppose the break is given and one of the switch cases have been executed, then the control would be transferred to the statement following the switch statement. Okay. Now, let us look into the conditions that have to be followed when we are going to specify the switch statement. You can have any number of case statements within a switch, that is switch cases as I said, and each case is followed by the value to be compared to and a colon. And the next condition is the constant expression for a case must be the same data type as the variable in the switch, and it must be a constant or a literal. So, this I had mentioned you. Then when the variable being switched on is equal to a case, the statements following that case will be executed until a break statement is reached. And again, When a break statement is reached, the switch terminates and the flow of control jumps to the next line following the switch statement, as I told you at the end. And not every case needs to contain a break. So, that is what we said, break is an optional statement. So, if no break appears, the flow of control will fall through the subsequent cases until a break is reached. So, the switch block is going and the switch execution is going to continue if the break is not specified. A switch statement can have an optional default case which must appear at the end of the switch. So, whenever you are specifying the default option, that should be given at the end of in your switch block. The default case can be used for performing a task when none of the cases is true and no break is needed in the default case. So, there we have how to make use of the switch statement in C. Now, let us look at the flow diagram of the switch statement. We have the expression that comes along with the switch keyword. In addition with this, okay, the control is transferred to that particular case for which this expression is evaluated. That is, after evaluation, the value of this, if it is equal to any of these switch cases, then it branches to that particular switch case and the respective code block is going to be executed. And then the control would be transferred out of the switch block in case where we have specified the break statement. So, let us look at a simple example which makes use of the switch statement. We have defined a variable called grade to be of character type, and we have also defined the value for it to be a uppercase B. Then we are using the switch statement where switch, and this is the expression over here. Now, this expression is just a literal which has a value already. So, this grade value, that is B, is compared with each of these case values. So, now when it compares with the case value, the first case value, that is A, it is not equal to. So, the control will be transferred to the next switch case, and here B matches with the value of grade over here, and here we have not given any statement, that is a null statement is here. So, what happens, the control will be transferred to the next switch case, and it says under this even though the expression is not matching with this case, the statement corresponding to that would be executed. So, here you have a printf well done and it breaks, and the program is going to be continued with other switch values like this with D and F, and we also have a default block then which says that printf invalid grade, that is if our switch expression is not going to match with any of those if the switch expression is not going to match with any of these case values, then maybe the default case would be executed, but in our case that is not happening, it has already matched with the value B. So, our final output would be well done, and then we had the last statement, that is apart from the switch block we had this statement your grade is. So, we are coming across two statements, that is well done when B was chosen and your grade is B. So, let us look back into the program. You have a variable grade with a value defined with it, and we are using this grade as an expression with the switch statement. So, it is trying to match with all the options, that is switch cases. When it finds a match, the respective statement is going to be executed. Since here we do not have any statement, okay, the control is going to be transferred to the next case, which is this. So, this is going to be executed, and then you have after the switch block, since we have given a break, the control is transferred out of the switch block. So, you have a output statement over here. So, this is going to be printed. Next, we have a special operator in C which we call as the conditional operator. The conditional operator has two operators, that is, one is the question mark and another is the colon. This conditional operator can also be used in place of the if else statement, provided that we have only two options over here. That is, you have the general form of this would be expression 1, we are checking with the expression 1, followed with if this expression 1 is evaluated to a true value, then expression 2 is going to be evaluated or chosen. If this expression 1 is going to be evaluated to false, then expression 3 is going to be chosen. So, that is what has been explained over here. So, now let us look at a simple example. We have a variable y is equal to a value 1.5x plus 3, where x would be less than or equal to 2 and y is equal to 2x plus 5 if x is greater than 2. So, we have two conditions, that is, if x is greater than 2, some value should be assigned to the variable y, and if x less than or equal to 2, and another value should be assigned to the variable y. So, how do we put this whole thing? By making use of the conditional operator, we could do it in this respect, that is, y is equal to x greater than 2, that is, we are checking whether x is greater than 2. So, that is why a question mark is put over here. So, if x greater than 2, what should be the value of y variable? It should be 2x plus 5. So, here if this is true, then put that value, that is 2x plus 5 over here. And suppose this condition is false. What does that mean? If x greater than 2 is false, means that x could either be equal to 2 or it could be less than 2. So, that is what we have the other condition, x is less than or equal to 2. So, if this condition becomes false, it is nothing but we are talking about this condition. So, the value of y would be 1.5x plus 3. So, that is written over here after this colon. So, in your conditional operator, you have one condition to be checked, and if based on the condition whether it is a true or a false, the truth value would be given over here, that is, the true value would be given over here, and the false value would be given after the colon. This conditional operator could be as simple as this, that is, using the conditional operator could be as simple as this, and it could be more complicated when you have more number of conditions. So, here you see we have three different conditions. Let us look at this problem. Consider the weekly salary of a sales girl who is selling some domestic products. If x is the number of products sold in a week, her weekly salary is given by certain values. So, here if x is less than 40, that is, the number of products that she has sold is less than 40, then her salary would be this. If x is equal to 40, it would be this, and if x is greater than 40, the salary would be this value. So, how do we phrase this particular condition in terms of conditional operator? We could make use of a nested conditional operator over here. So, here we are checking x not equal to 40. So, if x is not equal to 40, then what are the possibilities? The possibilities could be that x is either going to be less than 40 or x is going to be greater than 40. So, that is why we are again checking the condition if x is less than 40. So, if x is less than 40, it could either be a true or a false. So, if x is less than 40, then the true value for this would be specified over here. So, what is the value if x is less than 40? we have salary is equal to 4x plus 100. That is what we have specified over here. If x is less than 40, we have 4x plus 100. If this is not true, then what else is possible? It is possible that x could be greater than 40. Those are the only two possibilities now. So, if x is greater than 40, then what is the value that has to be assigned to the salary? It is 4.5x plus 150. So, that is what we are giving over here. Sorry, this is a colon over here. Instead of a question mark, this should have been a colon. So, here you have, suppose this expression is false, then 4.5 into x plus 150 is going to be evaluated. So, this is the inner conditional operator, fine. So, if you think this is the whole part of this one, this is the first part of your outer conditional operator. Now, just look into this. You are checking the condition x not equal to 40. If x not equal to 40 means that if this condition is going to be true, okay, this is going to be executed, this whole thing is going to be executed. If this condition is going to be false, that is what, x should be equal to 40. So, if x equal to 40, what should be the value of salary? It should be 300. So, that is what we are giving after the colon over here. So, now you see that the conditional operator is being used in a nested form. First, you are going to check this condition. If it is going to be true, that is x either greater than or equal to 40, then the first part is going to be executed. So, again in the first part you have another conditional checking. So, x less than 40, if that is true, then this part is going to be evaluated. If this expression is false, then the second part is going to be evaluated. And if this whole thing can be considered as one whole block, then if based on this expression 1, you have expression 2 and expression 3. So, if this condition is going to be true, this has already been evaluated. If this is false, then the value of salary would be 300. So, next we go to another statement, that is a goto statement. A goto statement provides an unconditional branch in the C program. So, branch unconditionally from one point to another in the program. So, immaterial of any condition, we are just going to branch from one place to another in a program. So, how could this be done? The flow diagram of a goto statement could be such as this. When we are going to use the goto statement, we need to have some labels also in the program. So, suppose we have labels in the program such as this, label 1, label 2, label 3, etc. Then, suppose we are using the goto statement, I could say go to a particular label number. So, here we are saying go to label 3, where the control at the beginning is over here, and we are going, when we specify the statement go to label 3, then the control would be transferred to this label 3, where the respective statement would be executed. So, here we could have either a forward or a backward jump. So, just look into this. Here we are using both the forward as well as the backward jump. The general form of using the goto statements is, we can specify go to the label name, and this label name has the same way how we specify the identifiers of the variable names. So, here when you say go to label name, the control would be unconditionally transferred to that particular label name where it has been specified in the program. So, that is going to be specified such as this, that is the label name followed with a colon and the respective statement. So, this statement would be executed in this case. This is a forward jump, that is we are jumping from one point ahead in the program. We could also have a backward jump wherein the label has already been specified over here with the corresponding statement, and then you are following with the other program code, then you come across the goto label name. So, then it gets back to that particular label and the corresponding statement would be executed in this manner. So, now the conditions how the goto could be used. The goto requires a label in order to identify the place where the branch is to be made, and a label is any valid variable name and must be followed by a colon. The label is placed before the statement where the control is to be transferred. So, this has to be followed in case we are going to make use of the goto statement. And also note that a goto breaks the normal sequential execution of the program. So, what is the meaning of normal sequential execution? Normal sequential execution is the straight line sequencing, that is one statement after the other statement, simply executing in a straight line manner. But here when we use a goto statement, this normal sequential execution of the program would be taking place. The statement or the statements between the goto label and the label could be executed repeatedly, and this happens especially in case of the backward jump. So, as we saw over here, this is the backward jump. You have the program execution like this. These statements are already been executed. Now, a goto label causes the control to be transferred to a point before or behind in the program. So, again these statements would be executed. So, in a backward jump, the statements could be executed repeatedly. Now, let us look into a simple example that makes use of the goto statement. You have two variables which we have defined as the double data type, and then this read is the label that we have defined over here. So, the label name along with the colon. Then we are inputting the value of a variable x over here by making use of the scanf function. Then we check the condition if x is less than 0, that is if the user inputs a negative number. Since this program is to calculate the square root of a series of numbers, okay, we are square root of a number, we are going to check whether the number is a positive number or a negative number. Since the negative numbers will result with an imaginary number, we are not going to consider the negative numbers over here. So, input a number that is greater than a 0 should be given to the user, and then we are going back to the read function, that is goto read. So, here when we when the program is executing this particular statement goto read, it provides a unconditional branch over here, and then it goes back to the read label. So, again you are going to read the variable, and after that you are going to calculate the square root of that particular variable and print out the result. Now, just a brain teaser for you. You have two variables x and y where both the values have been defined, and by making use of the conditional operator, we are assigning a value to this x. So, here you are checking the condition, and would you just be able to tell me what the value of x is now? Since x is less than y, 10 less than 15, the first part of this would be evaluated. So, it becomes y plus x, that is 25. So, we need not bother about the other option at all. So, the value of x would be 25. And what would be the output of this program segment here? You have a character by name ch that is assigned with a value lowercase a, and then you have the switch statement. Then you are comparing with the values over here, that is switch cases a, b, and then the default. So, what would be the output of this program segment, could you say? We will just look into it. You have the expression value as a. So, naturally the control would be transferred to this first switch case. So, you have a printf statement with the value a over here. So, this is going to be printed. And what happens next? Do we have a break statement over here? No, we have not specified the break statement. So, as I told you, the control is going to seep into the next switch case. So, it gets into this particular switch case and also prints the value of b over here. After doing this, it gets into the default case, then prints the value of this, and then comes out of the program. So, now you see the importance of using the break statement in the switch block. So, with that we finish the branching and the decision making and branching by making use of the if structure. Now, we will get into a more complicated structure that provides again the decision making and branching, but along with that we are also going to do an additional job over here, that is executing a statement or a set of statements multiple number of times, that is repeated execution we are going to perform. So, this kind of repeated execution could be achieved by the loop structures. So, programming languages provide various control structures that allow for more complicated execution paths. So, for that we are using a loop statement. So, what is a loop statement? It allows us to execute a statement or a group of statements multiple number of times based on certain conditions. So, here we are performing repeated execution and we are also performing conditional branching. So, this is a flow diagram. This is a general flow diagram of a loop structure. The control would get into this and then we are checking the condition. If the condition evaluates to a true value, then the respective conditional code is going to be executed, and after the completion of the conditional code, it gets back to the condition again where the condition is rechecked. So, if the condition now again evaluates to true, so this conditional code is going to be repeated. So, this repetition happens until this condition becomes a false value. So, once this condition becomes false, the control would be transferred to the next statement over here. So, what generally happens in the looping process, we will see, that is setting and initialization of a condition variable. Next, execution of the statements in the loop, and then incrementing or updating the condition variable, and then test for a specified value of the condition variable for execution of the loop. So, these are the general process that happens while we make use of the loop structures. And our C language provides three constructs for performing these loop operations. They are the while statement, the do while statement, and the for statement. Immaterial of whatever a loop structure we take, either it could be a while statement or a do while statement. The loops could be of two types, that is it could be a counter controlled loop or a sentinel controlled loop. So, what is this counter control loop? This is used when the exact number of times the loop has to be executed. That is, before the execution, if we know the number of times the loop body is going to be executed, then such kind of loop we will call it as a counter control loop. Some cases we will not know exactly the number of times the loop body is going to be executed. So, in such cases we call it as a sentinel controlled loop. So, here in the counter controlled loop, a control variable called the counter is used, which is first initialized and then it is going to be tested and then updated. Either it is going to be incremented or decremented so as to meet with the condition, and then it is going to be the updation is going to be done properly and the loop execution happens. And in case of the sentinel controlled loop, a special value called a sentinel value is used to change the loop control expression from true to false. So, this control variable we call it as a sentinel variable. Now, we will look into the details of the counter controlled and sentinel later. We will first start with the first loop structure, that is the while loop. The while loop is going to repeatedly execute the conditional code as far as the condition is true. So, look at the flow diagram of the while loop. The condition is first checked over here, and if the condition is evaluated to true, then the respective conditional code is going to be executed. This could be a single statement or multiple statements. And after the completion of this conditional code, the control is going to be transferred back to the condition, and then the condition is evaluated once again. If it happens to become false over here, then the control would be transferred to the next statement. So, how is it going to be used in the C programming language? So, the syntax for the while statement is going to be as follows, that is while test condition, body of the loop and then end. So, this whole thing will be called as the while block. Suppose we happen to have a single statement, then these braces are not required, but it is always a good practice to enclose the body of a loop structure within a brace, whether it be a single statement or multiple statements. So, what happens over here? The test condition is going to be checked. If it happens to evaluate to true value, then the while block is going to be executed. If the test condition becomes false, then this next statement following the while block would be executed, that is the while block entire would be skipped.